Hello guys, I'm a teacher Olimboka Nsujigo Masami. Welcome to Olimboka Physics. We want to use the pinhole cameras to calculate the refractive index of unknown liquid that is inside the pinhole camera. This pinhole camera has a length of 10 centimeter and the width of 16 centimeter with a radius of 8 centimeters, half its width. The camera is exposed to the air where it accumulates rays, parallel rays that come from the sky, and they refract it at point O. This is point of incidence. So refracting these rays, it comes down at the bottom where it meets the screen edge of the screens and forming a first image. Due to when this refracted rays meet this normal rays that hit the point M and returning back, as you can see here. But the observer here will see the image by concept of reflection, as the observer sees the full image on the screen. This screen, remember, is transparent or translucent according to the structure of pinhole camera. And by using the principle of reversibility of light, this refracted light rays will be as the incident ray. In these rays, refracted rays, incident rays will take the same path back to where it was started. Hence, the rays from the screens up to the point O will be as incident ray, with the same path. The rays from O to where there is the skies, the sun, is now refracted rays. That's why I put here a refracted angle R. Remember, this is angle R is such greater because the rays from the suns are almost parallel to the surface of this pinhole camera. We just take at a certain angle before it reach to 90 degrees here from the normal, so that you will have a constructions to show the refracted angle, which will give that will share the common opposite with incident angle. This incident angle, remember, is the same as this one because of the alternating angle, and this also is same as this one because these are corresponding angle. Hence, we can be in position to use the triangle MO and for image 2 and triangle MO for image 1. Remember, this image I darkened it because there is no image here. It's just to reconstruct it because almost this rays is at 90 degrees from the normal, and that's why the apparent position of this final image here is almost approaching to 0, as this image formed at the bottoms now will be due to total internal reflections, as this one is approaching to 0. Hence, this image formed at the bottoms here of the screen, now it will be due to total internal reflections. Hence, here we will apply the concept of total internal reflections to see the relationship between refractive index of this liquid inside the pinhole camera, the angle of incidence, and the constructed triangle for the angle of refracted. Okay, let us go and see how this relates. Now, after, as I've said, we must consider the two triangle, and now the sign of incidence with the same common, sign of refracted the same common, and this is the respective hypotenuse for these two angles. Now, this is common is cancelled out. Remember, we have this hypotenuse. Now, because this is concerning with total internal reflections, or the condition of no small angles, as the rays as seen comes parallel from the far source, that is sun. Here we'll have using the Pythagoras theorem for the case of image 2 and for the case of image 1. Now we'll have as this relation here, and then we substitute, and we have this formula, and we know here we define the Im dash, that is real height, and here we define double the second image and M. Now this is apparent depth, and OM, that is radius of this pinhole camera. Now we know this apparent depth is very small, and for this case the squares is approaching 0 of it. Okay, now when we substitute from these equations, these representations, now we'll have the formula, general formula, as you can see here, because this is square is cancelled to this one, and now we know that this apparent depth square is approaching 0, is taken as 0, and then this will remain with general formula as this one. And for a diameter d is equal to this one. Okay, then we'll have the depth, which is 10, and we'll have the radius, which is 8. We use the first equation. Then we'll have the approximately 1.6 refractive index of the liquid inside the pinhole camera. Thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.